Good morning to all. Myself Jayanthi, Assistant Professor, Department of Computer Applications, B.Sc College of Arts and Science for Women, Trichandur. Today we are see about operating system. Our operating system and process concept. Introduction to operating system, process management, interrupts and process communication, distributed and parallel computing overview. Introduction to operating system. An operating system is a system software that acts as an interface between user and hardware. It manages resources like CPU, memory, and I/O devices. For example, Windows, Linux, Android, Mac OS. The functions of OS: process management, memory management, file system management, and device management. Distributed and parallel computing. Distributed computing means multiple computers connected via network. Work is divided among systems. Example, cloud computing system. Parallel computing, multiple processors execute tasks simultaneously. It improves performance and speed. Used in supercomputers and scientific calculations. Process concept, process lifecycle and PCB. A process is a program in execution. Components of a process: program code, data, stack, heap. Each process has its own address space. Process state: new, ready, running, waiting, terminated. The process control block (PCB) stores process information, includes process ID, state, CPU registers, memory information. Used by OS to manage the processes efficiently. Interrupts and IPC. Interrupts, signal that stops CPU temporarily. Types: hardware interrupts and software interrupts. Interrupt processing to save the current state, to execute the interrupt handler and resume execution. Inter-process communication, communication between process methods, that is signals, message passing, shared memory. Mutual exclusion and critical section. Mutual exclusion ensures only one process or thread accesses the shared resources at a time. Prevents race conditions and data inconsistency. Critical section problem. Part of a program where shared data is accessed. The requirement is mutual exclusion, progress, bounded waiting. The mutual exclusion primitives are atomic operations, locks, semaphores, monitor. To implementing the mutual exclusion is hardware-based solutions, software-based solutions, and synchronization primitives. Software solutions for mutual exclusions have algorithms. First one is the Peters algorithm. Software solution for two processes uses shared variables and turn variable. Guarantees mutual exclusion, progress, and bounded waiting. Lambert's Bakery algorithm is generalized solution for n-thread mutual exclusion. Threads take numbered tickets similar to a bakery queue. Thread with the smallest ticket enters the critical section first. Ensures fairness and avoids starvation. The advantages is no special hardware required. Demonstrates fundamental synchronization concept. The semaphores monitors and message passing. Semaphores, synchronization variable used to control access to shared resources. The types is binary semaphore, counting semaphore. Thread synchronization with semaphores. Wait and signal. Wait is acquire resource. Signal is release resource. Implementing semaphores. Atomic operations and queue of waiting processor. Concurrent programming techniques. Monitors. High-level synchronization construct. Provides mutual exclusion automatically. Message passing. Processors communicate by sending, receiving messages suitable for distributed systems. Next, the introduction to deadlock. Deadlock, a situation where two or more processes are permanently blocked. Each process is waiting for a resource held by another process. No process can proceed, causing system halt for the involved processes. Resource concepts. Resource: any hardware or software entity required by a process. For example, CPU, memory, files, printers, I/O devices. The resource types is preemptible resources and non-preemptible resources. Preemptible resources can be taken away safely. For example, CPU. Non-preemptible resources cannot be forcibly removed. Example, printer. Deadlock. The mutual exclusion resource is used by one process only. Hold and wait. Hold resource, wait for another. No preemption. Resource cannot be forcibly taken. Circular weight P1, P2, P3 and P1. Circular weight example, P1 holds R1, waits for R2. P2 holds R2, waits for R3. P3 holds R3, waits for R1. The finally reaches the P1. Indefinite postponement, starvation. Indefinite postponement or starvation. A process waits indefinitely because other processes continuously receive resources first. The process is not blocked by a deadlock but never gets a chance to execute. Deadlock versus starvation. Deadlock starvation process wait for each other. Permanent process waits indefinitely for resource involved. Circular waiting. No circular waiting required. None of the processes progress. Other processes may continue executing. Prevention techniques. Fair resource allocation policies, prioritizing, first come first served scheduling, proper synchronization mechanisms. We see in the next class. Thank you.